Okay, for our second example of free fall, so let's free fall, notes, continued. So I throw a Barbie straight up with a velocity of 5 meters per second and catch her at the same height. So basically what I'm doing is, if we were to draw a picture, here I am, here's Barbie being thrown up into the air, and then I'm going to catch her again at the same exact height above the ground. So height, she lands at the same height above the ground. Okay, so we want to know, how high does she go at the peak? So how far up here? We want to know, how long does she take to reach the peak? So time, we know how high, so delta D. And how fast is she moving when I catch her? So V final equals question mark. So there's a few things that we need to know. So let's go ahead and start solving. So to solve for A, we want to write all of our knowns. Well, we know that her initial speed, V initial equals 5 meters per second. We know that she has an acceleration due to gravity of negative 9.81 meters per second squared. We know that her final velocity, because she's going to come to rest at that split moment up here, this velocity at the top is going to be equal to 0. Okay, so basically the Barbie's slowing down as she comes up to the top, and then as she comes back down, she's speeding back up. Okay, so V final equals 0 meters per second. We need to know delta D. So looking at our kinematic equations, we see that we involve V final, V initial, acceleration, and distance. So our equation is VF squared equals VO squared plus 2A delta D. Okay, solving for delta D, we can go ahead and do that before we plug in numbers. VF squared minus VO squared divided by 2A equals delta D. If that confuses you, you can plug in numbers first, whichever one works for you. So we go ahead and plug in numbers. 0 squared minus the initial is 5 squared divided by 2 times negative 9.81. We get delta D, which equals, go ahead and put that into a calculator. Need to grab one. So we get 5 squares, 25. 2 times negative 9.81 gives us negative 19.62. And you should get 1.27 meters. Okay, now we need to go on to B. So B, how long does she take to reach the peak? So we know the same things that we know in the previous problem. We know V initial equals 5 meters per second. We know V final equals 0 meters per second. We know acceleration equals negative 9.81 meters per second squared. And we know that our time, delta D equals VOT. We need to know time. So we can go VF equals VO plus AT. Although we'll have a negative number here, and in order to get, so let's just solve it. V final equals 0, V initial equals 5 plus negative 9.81 times time. We subtract 5 on this side, you get negative 5 equals negative 9.81 T. Divide by negative 9.81, divide negative 9.81. We get T equals 5 divided by 9.81, which is a little bit more than a half a second, so 0.51 seconds to get to the peak. So let's keep going. I'm going to move up the page so you can see the rest. So letter C, we want to know, how fast is she moving when I catch her? So how fast is she moving when I catch her? So our new scenario is going to look something like this. Here I am. Here's Barbie in the air. She just flew. Now she's coming back down. So if we look at the Barbie now, she is going to have a V final. So our V final equals question mark. We know how her V initial was 0. We know her acceleration is still negative 9.81. And what is something else we know? We know the distance and we know the time. So we can use either one of these because we're catching her at the same height. So let's use the distance. So delta D equals 1.27 meters. And now we can find V final. So our equation is going to be VF squared equals VO squared plus 2A delta D. So VF squared is our unknown. So VF is going to be the square root of VO squared plus 2A delta D. And we get square root of 0 squared plus 2 times negative 9.81. And delta D is actually a negative because of the displacement. It's the difference between start and finish. So we get negative 1.27. Go ahead and put that in your calculator. You should get the square root of 24.9. You get 4.99. 9917. Approximately 5 meters per second. So we can see that Barbie's V final at the end of her trajectory is the same as her V initial when we first threw her up. So she may be losing speed on the way up, but she's gaining that same amount of speed on the way back down in her path. Okay, the last question is how long is she in the air? So what is her hang time? Well, in order to find part D, which is her hang time, it is just going to be twice the amount of time that it takes. So if it took her 0.51 seconds to get to the top, that means it's going to take her 0.51 seconds to get to the bottom. So total time is equal to 0.51 seconds times 2, which gives us a little over a second. So 1.02 seconds. That is her hang time.